Chapter 4.6 covers isosceles triangles and equilateral triangles. Isosceles, by the definition for our class, is that only two sides of a triangle are congruent. And equilateral is that all three sides of a triangle are congruent. The isosceles triangle theorem states that if two sides are congruent, which making it isosceles, then the angles opposite those sides are congruent. So the base angles here are congruent. The converse is the opposite of it. That says if you're given that two angles in a triangle are congruent, then the sides opposite those angles are congruent, making an isosceles triangle. So in this first problem, we're asked to name two unmarked congruent angles. And since BC is congruent to BA, we know by the isosceles triangle theorem that angle BCA is congruent to angle A. So this angle here is congruent to this angle. Problem B asks us to name two unmarked congruent segments. In this picture here, we know that angle D is congruent to angle DCB, this angle here. So angle D is congruent to angle DCB. So by the converse of the isosceles triangle theorem, we know that BC is congruent to DB. So these are the answers for part A and part B. The next problem asks us which statement correctly identifies the two congruent angles. So if I look at PJM, that would be this angle here. Is that congruent to PMJ? Which is this one here. But I don't have enough information to show that. And the picture actually gives us that these two sides right here are congruent. So since those two sides are congruent, these two angles are congruent by the isosceles triangle theorem. So that would be JMK and JKM. So it would be this set right here. The next problem says which two statements correctly identifies two congruent segments. So looking at this problem again, we have that this angle right here is congruent to this angle here, which would give us that this segment is congruent to this segment by the converse of the isosceles triangle theorem. So we're looking for PM and PK. So it would be this statement here. A triangle is equilateral if and only if it's equal angular. So if all the angles are equal, then it's equilateral. If all the sides are congruent, then all the angles are congruent. So we're going to go back and forth. We've also discussed the next corollary, that each angle of an equilateral triangle measures 60 degrees because all the angles are equal, and we divide 180 by 3 and we get 60. So now we're asked to find the measure of angle R. So we're asked to find this measure right here. We're told that PQ and RQ are congruent because they both are 5 centimeters. So we know that these two base angles here have to be congruent. Well, the top one is 60 degrees. which leaves us 120 divided by 2, which tells us each of the base angles are 60 degrees. So this actually ends up being an equilateral triangle, because if they're all 60 degrees, this also has to be 5 centimeters. Which leads us into the next one, part B. Since it is an equilateral triangle, this would be 5 centimeters. And the next problem, we're asked to find the measure of angle T, so we want to find the measure of this angle. We're told that RT is 3.5 and RS is 3.5, so it's isosceles, and by the isosceles triangle theorem, the two base angles here have to be congruent, so it has to be 60 degrees. We're asked to find TS. We're told that this is congruent to this. This is 60 degrees, which makes this 60 degrees, which would also make this 60 degrees. So all three sides are congruent. All three angles are congruent, so since it's equiangular, it has to be equilateral. So it would be 3.5. We're asked to find the value of each variable. And we are told that DF is congruent to EF. And that these angles right here are congruent to each other, which would imply, since this is congruent to this, this also has to be congruent, which makes it an equilateral triangle. So if it's equilateral, we can solve for the sides. First, for y, 8y minus 5 equals 6y plus 3. So 8y equals 6y plus 8. 2y equals 8, so y equals 4. We also know that all three angles have to be equal because it is an equilateral triangle, which makes each one of these angles 60 degrees. So we know that 4x minus 8 equals 60, 4x equals 68, and x will equal 17. In the next problem, again, we're asked to find the value of each variable. This time we're told that it is an equilateral triangle because all three sides are congruent, which makes it equiangular, which makes all three angles equal to each other. So all these angles are equal, which tells us that 3x has to be 60 degrees because each one of the angles is 60 degrees. So x equals 20. So that rules out C and D. We know that 2y minus 6 equals 8. 2y equals 14. And y equals 7. So we have 4 different questions that relate to this figure at the right. We're first told that if AC, so if AC is congruent to AD, name two congruent angles. So that would have to be these two by the isosceles triangle theorem. So angle D. Angle C I'm going to have to name by 3 different letters because there are 2 different C's here. So angle ACD. I could also name this angle by 3 letters if I wanted to. I could also name it angle ADC. Okay. So the next problem gives us that if BE is congruent to BC, name 2 congruent angles. So it would be this angle right here and this angle right here by the Isosceles triangle theorem. So we have to use 3 letters to name these. So angle BCE, that gives us the one that has a C as a vertex. The other one would be angle BEC, that has E as a vertex. In the next problem, we're told that angle EBA, so angle EBA is congruent to angle EAB. Name 2 congruent segments, which would give us this being congruent to this. So BE is congruent to AE. If angle CED, so CED is congruent to CDE, so these 2 base angles here are congruent, name 2 congruent segments. By the converse of the isosceles triangle theorem, we would have this segment congruent to this segment. So segment CE is congruent to segment CD. In the next problem, we want to find the measure of angle ABC. So this one right here. Since AB is congruent to AC by the isosceles triangle theorem, angle B and angle C are congruent. So this would be 60 degrees. We want to find the measure of EDF. We want to find the measure of this angle here. Since ED and EF are congruent, the 2 base angles have to have the same measurement. So both of these bottom angles here equal each other. So I would do 180 minus 40 divided by 2. So 140 divided by 2, which gives me 70 degrees. So this would be 70 and this would be 70. Want to find the value of each variable. Since the 2 angles here are congruent to each other by the converse of the isosceles triangle theorem, we know that this segment is congruent to this segment. So 3x minus 10 equals 2x plus 4. X minus 10 equals 4. So x equals 14. For number 8, we're told that these 2 sides are congruent. So by the isosceles triangle theorem, we know these 2 angles, 2 base angles, are congruent. So if they are congruent, I can divide 90 by 2 and I get each one of these are 45 degrees. So 2x plus 3 equals 45. 2x equals 48. And x equals 24. Remember, when we do a proof, the first thing is to write down the given, draw a diagram if they don't give you a diagram, and then mark the diagram. In this problem, they have already marked the diagram for us, so let's go ahead and write the given down. CD is congruent to CG. DE is congruent to GF. So given. So our given was that CD right here is congruent to CG. We're given that DE is congruent to FG. And we want to end up proving that CE, this one right here, CE equals CF. So it looks like we need to prove the 2 triangles on the end. This one right here, we need to prove that CDE is congruent to CFG. And we already have that these segments here are congruent. So really, we need either another segment being congruent, but that's a segment that we're ending up trying to prove congruent, or we need an angle that's between the two sides. So since I've been told that this is congruent to this, so since CD is congruent to CG, we have that triangle CDG is isosceles. Therefore, I know that angle D is congruent to angle G. And I'm not even sure that we really need this proof right here. Because our theorem says that if two sides are congruent, then the two angles have to be congruent. So let's just label this number 2 and say that angle G is congruent to angle G. So angle D is congruent to angle G. And that's by the isosceles triangle theorem. So now since we have that this angle is congruent to this angle right here, we can say that triangle CDE is congruent to triangle CGF, and that's by side angle side. So therefore CE is congruent to CF by CPCTC. Corresponding parts of congruent triangles are congruent. And that concludes our lesson for chapter 4-6.